Okay. Right. Hi everyone. I think we are reasonably complete for today. Yeah. No one missing. Well, I think class really empty again. That's good. So that's more focused now. Last session was mostly about setting up the environments or not setting up the environments and getting something showing up or probably not showing up. So how many people actually finished, saw something showing up on their screen apart from their own IDE? All right, 2 people. So no one else managed to get to the triangle thing? No? Yes? Perhaps? I know. Sorry? Yeah, you got there? You got there as well. Good. So that's good. I mean, we had the same impression running around here, seeing that things didn't really work out the way we expected them to. So 2 things. So as a response to that, it seems the part of the issue lies in the underlying framework, windowing framework. So we didn't talk about it yet, but as it turns out, OpenGL actually is only responsible for rendering stuff on your graphics card, right? Nothing else. It doesn't do keyword handling, no networking, not even setting up the window, right? The beautiful window that gives you something to output. So because it's depending on your operating system. So we need to use frameworks to deal with that situation. And one of the frameworks we used in the last code was GLFW. In fact, I didn't even want to talk to you about it much because it doesn't really matter. We're doing OpenGL and those are just helper tools. But it turns out that this is incompatible with most Intel GPUs that you guys having, particularly the onboard ones. And there were some cases where we can't use the dedicated graphics card, so we need to fall back to that GPU. And what we did as a response is to write the code and the instructions for that first lab to use a different framework called SDL, which apparently is better in cross-platform compatibility. It's a bit richer, a bit heavier, has more features, has networking support and so on. Stuff we don't really need. The only thing we need from it is actually to show us this bloody window and to actually render some OpenGL in there, right? So yeah, that's precisely what this session is largely about. For the ones of you that actually did the lab, there's still no harm. I'll just bring up the instructions briefly. So the instructions have been updated, and they will eventually, within timely come up. So we are for now throwing us out GLFW. If in worst case, that's the worst possible case, some people can't work with SDL either. We need to find a hybrid approach that works with both. But anyway, right now we introduce SDL2 as the lightweight platform library that we're going to use. And so it affords you to, or requires you to rewrite, or sorry, to adapt some of your environmental settings. So you'll need to download that library and set it up as well. I was also more precise about specification of what to download. I noticed in the last session that people were unsure whether to download sources or binaries, 32-bit, 64-bit. So it doesn't really matter if you have 64-bit or 32-bit libraries as long as you're consistent, right? So pick the same ones. And I just heard here that's pretty hard to actually find the glue 64-bit libraries.
No, it was actually in the folder.
Oh, okay.
So both the 32 and 64
cool.
folders in simple.
Sweet, cool. So that should be available. It's important. Pick consistent platform architecture binaries and choose the developer versions as well. We don't just want to run code; we actually want to build code. So we are a bit more on the developer side of the end, not just using it. I was also more precise about how to set it up in terms of the dependency management. The rest is largely the same. Few more commands. In Ubuntu Linux is one command away, and you have SDL2 installed. That's quite convenient, beautiful. And then the task continues. So the idea is, once you get the code, you should see something like this. So it means, oh, cool, you have your framework running, your setup running. And once you are there, you should start modifying and see if you can produce something like this. Quite straightforward. It's just basically mucking around with the metrics information that you have and get comfortable with dealing and modifying it, right? So for everyone who didn't do the lab yet at all, or didn't arrive at that stage, just follow that lab. So that's probably the best way to deal with this. I briefly go into the organization of the libraries in a second. for everyone else who did this already, please adapt. So create a new version of your project and try to rerun it with SDL as well. I want to see if it really works on all machines, but keep your old running version. So if you have a running project, keep it, right? Keep it separate. And for the ones that want to speed ahead, well, there's not much speeding here, but you can go ahead. There's some mini extensions you can do. They include using keyboard handling to actually modify the window. So we get comfortable with this as well. Eventually, everyone needs to do it because you want to. What do you want to do actually as part of this course here? No? Yes? What's the specialization you guys are in? Hopefully.
Games.
Ah, games, cool. You want to write games. Games generally have this interaction thing going on, right? So we need to have keyboard handling anyway. So it's something to deal with. So, but anyway, that's on the wiki as well, if you like. I also put a link to the OpenGL website and the API reference. Actually, quite helpful if you want to figure out what a function is generally about. And by convention, the only thing that we probably can discuss meaningfully right now is that OpenGL functions generally start with GL. GL, there you go. So that's quite important. Whereas functions that are related to framework of choice, so it's it's built up like the usual API documentation. You need to find the function of choice, and you can find the signature and some brief description. It's at least a good starting point if you want to know what a function is about before diving deeper into something else. Not the most beautiful documentation, but quite functional and has examples as well here and there. So, but this is only as a side note. But if we now look at the code, for example, that I provided you, so the code file has been updated as well, right? So be mindful of that. So functions that start with SDL or whatever else, they're specific to this handler framework. So don't get all wrapped up in that. That's just boilerplate stuff. The interesting bit comes when the GL function starts. That's where you actually need to pay attention and probably start modifying. Cool. So I'll just briefly highlight the different structure of the code right now. Previously it was all pretty much sequential in one main method. Here we have actually a main method that spawns out quite a bit into uses other functions predominantly. So the idea here is that we're setting a clear background OpenGL and then actually open the window and actually do some sort of
excuse me?
Running of the game. Yep.
Can you zoom in?
Oh, that's a good idea.
Or is this
maybe turn off the lights?
accessible?
Yeah, that's my issue, the lights. Did anyone figure out how to turn off the lights?
I think you can only do it back in
There you go, that's a bit better, isn't it? Yeah, that's better. Sorry, there was some comment? Ah,
Perfect.
thank you very much. There you go. My extended, yeah, cool. Thanks, that's a lot better. I was looking for it last time already, so it's cool. So we're getting somewhere. So we basically have one main method there, doing some init. The init stuff, let's have a look at this briefly. Bit of navigating around here. Of course, you can explore it later on your own. I'll just give you a brief primer. It initializes the SDL subsystem. Everything you see here is pretty much dependent on the windowing framework that we're using. So it's all boilerplate stuff. If you write your own application, you pretty much can take that one-to-one, hopefully, without much modification, apart from things like resolution and things like that. But it's kind of stagnant and constant. So we'll probably reuse some of that one. It then calls set OpenGL attributes, which is most significant. So firstly, it creates a window, obviously, and an OpenGL context that's attached to this window. Then it sets the attributes. They are down here. What are the attributes that we find? We are using the core profile. We didn't talk about this yet, but the OpenGL core profile, we'll talk about this in another stage. And we're using right now major version 3, minor version 2, so OpenGL 3.2. Right now, what to do. And it sets up double buffering, which we talk about as well in the next session. It's a bit confusing right now because we had 2 lab sessions in a row without a lecture in between. And the reason I don't think I have elaborated on this is that we need to swap for scheduling reasons the labs and lectures from Monday to Friday or Friday to Monday. You choose. Meaning on Mondays we will have labs, on Fridays we will have lectures in the future, right? Because of some scheduling things. But we'll talk about all those details in the lecture. That's why I don't want to go too deep right now. I just want to give an intuition of what's happening here, so you can do the lab and have a rough feeling what's going on, and then it will make more sense after we had our talk on Friday. So it sets the Opengl attributes. Let's go back to the main method so we don't get lost. So it was all part of the init. Then it sets, this is actually an Opengl instruction. It actually sets a color for the window buffer. So basically that's which color probably? Anyone?
I can read that.
No? Okay, shit. Sorry. Language. So let's see. Can we fix that? Is it more legible? No, not. That's worse. All right. So, any guesses?
Black.
Cool. So, so that would be the base color. What else do we have? And then we're actually swapping we're swapping the window in the foreground. So that's the key idea. Right, so the more interesting bit here is down here, run game, and that's where the actual magic happens. So a background is set, and well, the comments give it away, dark rose. You read this in the last version of the lab already. So, and then we have a vertex buffer, so which specifies some, vertices with x, y, and z coordinates, right? So quite straightforward. And without going much into depth here, it basically links this, at this stage, C++ code to the OpenGL corresponding, entry points or buffers and vertex arrays and vertex array objects and so on. We talk about this in the lecture to ultimately display it then on the screen. So the actual displaying then happens only down here. So it's a lot of boilerplate stuff going on that actually just for the purpose of linking up. And this one says, well, draw whatever you have in this input array in the form of triangles, meaning interpret 3 points as 3, no, not quite, no? So 3 points as a triangle. So if you have 9 points, you have 3 triangles, right, as opposed to individual points. There's different primitives to indicate. So for example, another alternative would be GL points. It would just draw individual points, but not connecting them. So that's one way of dealing with it. Yeah, basically starting from the first entry in this array and doing it 3 times for 3 vertices. So. Cool. Afterwards, we disable this this connection between the input array and OpenGL, and then we update the window again with with possible changes in the background. So we talk about this later, but the idea is of we use the notion of double buffering. So you write an image or in the background and then swap it to the foreground, so you don't actually see the writing process, and that's the swapping of the windows that's happening here. So this is running in a loop. So this is continuously running in a loop. So you notice actually OpenGL will redraw your triangles as opposed to having static image, which you perceive this way. It's actually a continuous redrawing. So you may also potentially see some load on your machine in that respect. So more importantly, however, is here this one. This is a loop, and there's a conditional loop which is attached to this loop variable, which is evaluated a result of the evaluation of poll events. So let's go to poll events. There we go. And here we see we have a bit of a fallback into the framework again, right? That's why I didn't put this into the main code, because I want to separate that framework and OpenGL. And we find it just checks if an event corresponds to a quit command. So quitting generally means pressing, in this context, it's pressing the close button on the window, right? The top right button. So this one here, this is the SDL quit command. So if this button has been pressed or this function has been evaluated positively, then or not positively, then it's yeah. If it returns false, that basically means stop running the while loop, right? So basically, it runs to false, and then the while loop finishes. That's it. Your project closes. Your program closes. If not, return true. What's happening here in exit key pressed is basically delegated up here because it's a bit more complex. Again, it's SDL specific way of evaluating key press events. So you have a given event. If this event is a key press, so key down, if at any stage there was a key press, evaluate the code of the pressed key and then do corresponding returns. So if you, for example, press the SDL escape key, return true, and so on. So you could basically freely extend this with different cases for different keys that you want to evaluate for and do corresponding actions on, right? So, and this would basically wrap up the entire program in a nutshell, in a very high-level nutshell. Thoughts and questions for now? Yeah, please, Jonas.
Event.key.key7.0.
Yeah, that's right. What do you suggest?
I don't know. I have no clue.
Yeah, it's that's specific to SDL. I was fairly surprised as well. I would have expected to be much more flat structure in terms of evaluating a key, but apparently it evaluates the symbol table for different keys. So that's actually only holding the different representations for all individual pressed keys. So, yep. But yep, suggestions? No? Okay.
What that function, what that does is that it allows your keyboard mapping to be correct. So that if you say press F, it will correspond to F on your keyboard and not the default F of your OS.
Ah, okay.
Because what you can evaluate by keyboard numeric input value, which is just the numbering of the keys laid out on the keyboard, but that's a lot harder to deal with. Okay.
There's the answer. So, cool. But this is part of the SDL boilerplate stuff again. So, but it's worthwhile to understand it a bit so you can modify it, because in the lab, the extended lab, that's the idea, that you actually link this up, so your keyboard handling with modifications to the rendered output. So it's the key idea. Anything else I wanted to mention? Everyone clear, roughly? Because I want you guys to dig in to get that stuff finished eventually. Yep.
Just a small detail, but shouldn't you send the event by reference, or would that?
Yeah, that's right. I probably should do that. Yes, that's right. Yeah, we need to modify that. Yep.
Yeah, it's a
thank
big object.
It's
Because
no, the event shouldn't be too extensive. No, I think it's that's a valid concern. Shouldn't be too expensive, but I agree it should be sent by reference. Yeah. Cool. What else do we have? Cool. Afterwards, some cleaning up. That's the final thing, and that just basically boils down to showing eventual errors and closing the window. Okay. So that's the code bit. We come back to that on the Friday session anyway, and we link it to whatever we talk about there. And that's basically it now. So I would like you to continue a little exercise in setting up your laptops. Is there anyone that has expertise in Mac OS and Linux dual boot?
on a Mac machine or
On a Mac machine, of course. Do people do those things?
Rarely. If they do it, they use bootcamp.
Right.
Like if you don't use bootcamp, then you will have driver issues, like a lot of them.
Okay. So yeah. Okay. So that's yeah. So that's basically your answer. Okay, we need to think about how we can work around this. The Mac people, by the way, I didn't provide instructions for the Mac people in general. How did it go with the OpenGL setup? No one left of them? They already left us? No, come on.
They're here.
Yeah. Ah, there. Yeah, this is one. Yeah. But you're a special case because you want to run Linux on your Mac, right? Right. So who's running?
So I was wrong. I was thinking about the Windows. So with Linux, it's not driver issues, from what I can recall. I've tried it before, and I don't think I had any problems.
Okay. Right. I'm just. Yeah. I don't know. The only concern is that the 3D support is, you know, in any way affected by using Boot Camp. But I don't know. So it's just I don't have personal experience with that. So.
Yeah, but like
debugging.
I think it's just for Windows. So
Okay.
You don't need that for Linux.
So did you run Linux on your machine?
Yeah, but it was several years ago, and I didn't do any graphics.
Yeah. Okay. Okay. Cool. Jonas, native Mac user.
No dual booting, no.
Dual booting with Windows, though, right?
No.
Okay.
Just in virtual machine.
Ah. Okay. Okay. All right. Okay, that's an interesting challenge then. Yes. Cool. Need to think about this more. Good. Before I forget, that's what I wanted to say. The resources should be available here on the wiki page, but I would like you to log issues, and the reason is twofold. The reason is obviously to document the potential issues that we had, because we don't need to reinvent them frequently, or let's say every year, because I believe some of them have been experienced in the past years. So if you, for example, have a particular GPU and you really don't find drivers for that one, that's probably worthwhile noting it down, so we know for the future, okay, if you have that environment, you probably won't be successful, or if you have been successful in setting it up, but needed to do some workarounds on your machine, it's probably also worthwhile to provide as specific as possible information about your system and how you actually achieved it, right? So for this purpose, I would like you to log issues. It doesn't mean that we solve everything and so on, but it means at least we have a documentation initially, and perhaps people can, spawn some insights, or we can see if we solve it somehow. So the issue tracker should be available to you. If it's not, let me know in the wiki, and you know how to log issues. So you create a new issue. If you have a setup-related issue, I would suggest to use the label platform. For anything else, create a new, reasonably, meaningful label, I guess. So, but this way you could easily group those as setup problems, as opposed to development problems that we face later on. Right? Questions? Yeah.
Does anybody have a 2 GB or larger USB stick I could borrow for this class?
Well, like for the entire class, or just for now?
None for now. Is it okay if I erase everything on it to install?
Yeah.
Yeah.
Right,
Sure.
I have to do a quick.
Thank you.
So I haven't looked.
Of course.
I suppose it's not a question, but I tried the STL version,
Yeah.
this one.
Yep.
And it failed. I have the same issue as with the last one, so I get a background, but I do not get the triangle, and it's even worse that I don't get the.
Appreciate it quite a bit. Either as direct feedback or via issue tracker or email or whatever else. Cool. So yes. All right. So I'll be walking around, and we support you in terms of continuing your lab and setups. And I'll probably switch off the stream because there may not be something meaningful anymore to talk about other than watch the screen.